All right, numeric type conversion. What is that? This might be a little bit interesting. Numeric type conversion. Conversion. Okay, just to convert. Does it mean that we're gonna be converting maybe an integer to a float or a double? I don't know. Let's see. Let's see how this goes. Or we're gonna be converting integers to strings, which I don't know how that's gonna happen, but I see it appears that it's not a lot. But I think there's a lot to talk about, especially in numeric, because I see there's integer conversion, there's integer and floating point conversion. Okay, type aliases, booleans. By the way, we're still on the basics. I mean, we've not even gotten to the interesting parts yet. There's subscriptions, there's methods, there's classes, there's enumerators, there's operation, optional chaining, memory safety, access control. Now we're still right on the language guide. Well, I don't know what this is. Language reference. Let's see what it has in store for us. Types, expression statements, declarations, patterns, generic revision history. So I guess this helps you to know how to revise your work. Update. Revision history. Is this the history of the versions that we... Oh. Okay, maybe probably it shows you when what was made. When? So Swift is still a young language. It appears that it came in 2014. New documentation that describes Swift 1.0, Apple's new programming language for building iOS and OS and OS X apps. Anyway, we're still here on language guide. I think that's where we are. Cool. And we're still on the basics. And we are here. We did floating point numbers, we did type safety and inference, we did numeric literals, we understand how we can add underscores to help us read the numbers that we're working with. Now we're on numeric type conversion. What is numeric type conversion? Good question. What is this actually? What is numeric type conversion? Numeric type conversion. Conversion. Okay, what is this? Okay, let's see what this is. Use the int type for all general purpose integer constants and variables in your code, even if you are known to be non-negative, even if they are known to be non-negative. Okay. Using the default integer type in everyday situation means that integer constants and variables are immediately it means that integer constants and variables are immediately interoperable. Pretty much, I guess it means they can work with each other. Let's search the word. Able to exchange and make use of. Okay, they can work with each other in your code, and where they are immediately interoperable in your code and will match the inferred type for integer literal values. Okay, so we understand what inferred type was in the beginning. Okay, I see what that means. Okay, cool. Use other integer types only when they're specifically needed for their task at hand because of explicitly sized data from an external source. Because of explicitly sized data from an external source, or for performance, memory usage, or other necessary optimization. Using explicitly sized types in this situation helps to catch any accidental value overflows and implicitly documents the nature of the data being used. Okay. Integer conversion. The range of numbers that can be stored in an integer constant or variable is different from each numeric type. An int8 constant or variable can store numbers between negative 128 and 127, whereas you... Okay, I see that now. Remember how we once battled with this? Wow. So int 8 can store a lot of numbers. Let's see. Var. Okay. Just want to jump here. Okay, cool. I just want to test this out. Var h. And I will make it as an int 8. Whoa, so that means I can have 128 of these numbers. I don't know if it's 128 already or more or less, I don't know, but okay, probably that's a lot. Let's see. Overflows when stored into int 8. Cool. So I don't know what 100. Again. So you want to tell me that this is more than 128? Oh, but it cannot be. Can I just delete all this chunk here? Okay, I don't think I read it properly. Int 8 can store minus 128. It's happy with that. But in the moment that I say 127, which is it less or more? It's more than 128. So the moment that I store 129, which is less than 128, it gives me an error. It doesn't allow it. Cool, interesting. So I see where this is going now. And then var h int 8 is equal to 127. But then why would you want to have something like this? Well, there's a reason why people want to have something like this. Obviously, I think the more we understand this, the more we will know why. There's an int 8 which can only take values between, because remember there's a range. It's not the total number. What is this? It's not the length. Yes, I think it's not the length. It's the range of values that it can take, or it's the maximum number and the minimum number. Cool, not the length of numbers. That's where it gets interesting. Whereas you int 8 constant or variable can store numbers between 0 to 255, between these many numbers. A number that won't fit into a constant or variable of a single oversized integer type is reported as an error when your code is compiled. Okay. Can't store negative numbers, so this will report an error. Yeah, well, I think it's quite cool. It's quite cool how this can be the case. What I like about them is that you never want to go back down to negative numbers. That's where it gets interesting here. So there might be useful tools when you want to make sure that you don't have to go below those numbers. And the reason why I say they are wonderful tools is because they would prevent you from, what is this? Imagine having to write a check where you have to check if the number is less than 0. You can just make a number a UI int 8, and if it throws an error, therefore you got your answer. So that's a powerful check there without even having to write a check statement or anything like that. That's very beautiful. I like this. I like where it's going so far, especially if you want to make sure that you can filter out all the negative numbers, and yet you know that your numbers will not exceed 255. Cool, let's see. Because each numeric type can store a different range of values, you must opt in to numeric type conversion on a case-by-case basis. This opt-in approach prevents hidden conversion errors and helps make type conversion intentions explicit in your code. To convert one specific number type to another, you initialize a new number of the desired type with an existing value. In the example below, the constant 2000 is of type uint16, whereas the constant 1 is of type uint8. they can't be added together directly because they are not of the same type. Instead, this example calls uint16.1 to create a uint16 initialized with the value of 1 and uses this value in place of the original. Okay, I was not paying attention. I was reading that. I don't even remember what I was reading there. Because both sides of the addition are now of type uint16, the addition is allowed. The output constant 2001 is inferred to be of type uint16 because it's the sum of two uint16 values. Well, that makes sense because obviously I think we talked about it before, how if we add 0,3, or let's say 0 or a 3 plus 3.4, and we type infer that number and we use type inference, the number will be declared as a double precision number, or as a double variable, because of what is this, the floating point number that is included there. So let's continue here. Some type of initial value is the default way to call the initializer of a Swift type and pass some type. Okay, I see what it means now. Because we have some type here. I guess we did this once upon a time where we were trying to convert a number into another number, but then obviously we were trying to convert a double into an integer. But then here's where it gets interesting. If you want to convert an integer, you might find out that if you want to convert an integer into another number, it's going to give you an error. That's one of the interesting things about it, right? But I love this thing because it's powerful, because it means I'm just excited of using this, because the reason why it excites me is because the error is already handled for you. You don't have to do it afresh. That's what I like about it. Some type is the default way to call the initializer of a Swift type and pass in an initial value behind the scenes. uint16 has an initializer that accepts a uint8 value, and so this initializer is used to make a new uint16 from an existing uint8. You can pass in any type here. However, it has to be a type for which uint provides an initializer. Extending existing types to provide initializers that accept new types, including your own type, is covered in extensions. Do we have extensions anywhere here? Where's extensions? What I see? I want to talk about extensions. Where do we see extensions? Where's extensions at? Okay, cool. So we're gonna get to extensions. For now, it's beyond the scope of what we are at, because we're still on the basics here. So we're gonna get to extensions. But okay, I didn't really understand this. I think for now, maybe the thing that was in my mind a lot was that you can obviously convert integers together. But then the one thing that was constantly in my mind was how I can use this as a tool to check errors. Hey, what's up? Oh, and cool. I think, like I was saying, one of the things that excited me the most was how you can pretty much make use of this for testing your errors. It's so beautiful. I just like the thought of that. So I think we're going to end it here for integer conversion, numeric type conversion, and then integer conversion here. So we're just going to leave it here. And then the next video that we're going to have is integer and floating point conversion. That's one of the interesting things that we're going to have here. And we're going to see how it goes. Type aliases. If at least by today we can finish all the basics here, then I think I'll be happy. Then tomorrow we can begin with basic operators and see how far we can go with it. And it seems like the content is very short, because obviously there's so much that you can talk about basic operators, and then strings and characters. Strings and characters are very beautiful. Okay, let me just end the video. All right, cool, guys. Cheers.